A picture. So we did a cone here where it says the diameter is 3 times the altitude or the height. So if we wanted to make that a radius, we would switch it around, so you have 3/2 the height would be your radius, which is actually 6, but we'll get to that later, and we write that there. The other thing you want to remember is the rate. So the rate that the gravel is falling onto the pile is 17.4 feet cubed a minute. And so that's going to be dV over dt. So with this first problem A, you want to, at what rate is the height of the pile changing? The find statement is find dH over dt, or the height when the pile is, the rate of the height when the pile is 4 feet high. The first thing you want to do is write out your equation, which is V equals 1/3 pi r squared times the height. The second thing you want to do is you want to plug in 3/2 height for r. Now, the reason why we're doing this before we take the derivative is because it's going to be constant. It's going to be 3/2 the height no matter what the height is. So that's going to stay, and you can plug that in because we want to get rid of the r and we just want to solve for h. So next you're going to simplify it further. So 3/2 the height squared is just 9/4 height squared times h, which you end up simplified is v equals 3/4 pi h cubed. Now you're going to take the derivative of that. So dv over dt equals 9/4 pi h squared times dh over dt, or your derivative. Because of implicit differentiation, you always want to have this dh over dt for the specific problem. So then next you're going to plug in your values that come after. You take the derivative, so dv over dt, as we recall here, is 17.4. So 17.4 equals 9/4 pi, and you want to plug in your height at that point, which is 4, and squared times dh over dt. You want to simplify that out, so you get 17.4 equals 36 pi times dh over dt. You want to find dh over dt, so you take 17.4 divided by 36 pi, and you get 0.1538 and many more numbers. So for your answer, you're going to simplify that to, you're going to round that to 0.154 feet a minute. So at what rate is the height of the pile changing? It's 0.154 feet per minute. Now part B, it's find dr over dt when the pile is 4 feet high. So this is when you want to find the radius, when the rate of the radius is changing. So that's our find statement. So the first thing you want to do is you want to put your equation, v equals 1/3 pi r squared times the height. Now, as we recall from up here on the diagram, the radius is 3/2 the height. But because we want to just find the radius and we want to get rid of the height and just have all r's, you need to switch around that equation, manipulate it so that you have h equals 2r over 3, and you're going to plug that into your original volume equation. So you're now going to have v equals 1/3 pi r squared times 2r over 3, and simplified, that's v equals 2/9 pi r cubed, right here. So then next you're going to take the derivative. So if you take the derivative, you have dv over dt equals 6/9 pi times r squared times dr over dt. And you're going to plug in the values that you're going to plug in after the derivative because they were not constant and are changing. So that's why you're going to plug in your radius as 6 there, and 17.4 as we recall from here, there, and your radius, which is 6, because if you do, if the diameter is 3 times the height and you want the radius 3/2 the height, if your height is 4 would be 6, so you're going to plug in a 6 there times dr dt. So simplified, you get 17.4 equals 24 pi times dr dt. You're going to divide out 24 pi from both sides of the equation, and you're going to get your answer of 0.231 feet per minute. So the rate at which the radius is changing is going to be 0.231 feet per minute.